Hello viewers and my dear students. Welcome to application problems under projection of straight lines. These are all very important in the sense once you understood straight lines, how you have to apply, and the application part is a crucial part in application of straight lines. Okay, because in any industrial drawings the problems will be given, and in order to understand the problems clearly, you need to know this projection of straight lines, particularly the applications part of it. Okay, I will do certain problems here where you'll know what exactly is the use of projection of straight lines under applications. Okay, now see here problems under application of straight lines. Okay, see here carefully. Now, to understand this, first we'll understand what exactly the scale. Because in any application problems, they'll give it, they'll give that is problems in meters, sometimes kilometers also, sometimes centimeters. So many things will be there, but you have to accommodate on a drawing sheet. Unless you take a scale, you can't do the problem. That means sometimes they themselves will give choose this scale. Sometimes use convenient scale. When they say convenient scale, you should have a good imagination that what should be the size of the scale, what should be the that is what that is scale size you have to take in order to complete the problem. That means scaling is very important here. See here, scale is drawing size by actual size. If the scale to be adopted is 1:100, let us say in the problem, they adopt a scale of 1:100 or 1/100. If they say, you see here, you substitute here 1/100, you say substitute. Then actually 1 by scale equal to drawing size by actual size is equal to 1/100 means 1 centimeter drawing size is equal to 100 centimeter actual size. Okay, but actually 100 centimeter is 1 meter. That means this is same as taking a scale of 1 centimeter is equal to 1 meter actual size. If they say wherever you let us say 4 meter, it is there in a problem for one particular dimension, their unit is 4 meters. If it is 1:100, okay, it is 1 meter is 1 centimeter. Okay, 4 meter means 4 centimeter or 40 mm you take. Yes, same in the same way. Let us say in another problem they give 1:200. If they give 1:200 or 1/200, then 200 centimeter actual size is 1 centimeter drawing, or 2 meter is equal to 1 centimeter. Okay, did you follow? That means 2 meter equal to 1 centimeter. Okay, in that way 10 meters means you write it as 5 centimeters. Okay, or 50 mm. In some problems they may give 1:400. When they say 1:400, immediately you take 4 meter. Every 4 meter you take it as 1 centimeter on the drawing. That is, on the drawing you take it as 1 centimeter only. If it is 1:500, that is 5 meter is 1 centimeter. In the same way, if the scale to be adopted is 1:50 means in the same way you go 1 centimeter drawing size is 50 centimeter actual size, or 0.5 meter actual size is 1 centimeter drawing size. Can you follow? That means for every 0.5 you take 1. That means 1 meter you take it as 2 centimeters. Okay, 1 meter you take it as 2 centimeters. If it is 1:100, 1 meter is equal to 1 centimeter. If it is 1/50 means for every 0.5 meter you take 1 centimeter. Let us say the scale adopted is 1:25. Let us say 1:25. If it is 25, then 1 centimeter drawing size is 25 centimeter drawing size, 25 centimeter actual size, or 0.25 meter actual size is 1 centimeter drawing size. That means you know very well, for every 0.25 meter you take 1 centimeter, or for 1 meter you write it as 4 centimeter on drawing. That means on the drawing sheet, okay, if it is 1:25, or if it is 1:25 is the scale, then for every 1 meter you write it as 4 centimeter. That means anyway this scale concepts and all that I tell you. Okay, the basic thing you understand at this stage is 1:100 means, if you look to this, 1 meter equal to 1 centimeter. Okay, 1:200 means 2 meter equal to 1 centimeter. 1:400 means 4 meter equal to 1 centimeter. If it is 1 is to 50 means 0.5 meter equal to 1 centimeter. In that way you do. Otherwise, sometimes they don't give the scale at all. Then choose a convenient scale. Whatever that is, when they ask you a convenient scale, what scale to be chosen and all that, you have to think and do depending on the maximum dimensions, because you are doing it anyway on A4 size drawing sheet. It should be accommodated in A4 size drawing sheet where 210 by 297. Okay, this will be 210. This will be 297 mm. You see that the entire drawing comes on a 210 by 297 A4 size sheet. You have to adopt a convenient scale. Okay, this is the basics of scales. I have told you, never you forget. Scale is always equal to drawing size by actual size. Okay. Now you see here, a room is 5 meter long, 4 meter wide, and 4.5 meter high. 4.5. A fan is suspended vertically from the center of the ceiling at a distance of 0.8 from it. Okay, from the ceiling it is hanging at a distance of 0.8 meters. Find the distance of the fan from any of the ground corners, and also find the slope angle connecting line with the ground. Okay, find the distance of the fan from any of the ground corners and the slope angle of the connecting line with the ground. Take a scale of 1 is to 100. The given scale of 1 is to 100 means compulsorily you have to take scale of 1 is to 100. 1 is to 100 means drawing size by actual size. Actual size, drawing size is 1 centimeter. Actual size is 100 centimeter. 100 centimeter is 1 meter. That means take 1 meter is equal to 1 centimeter. Is it okay? The scale compulsorily, when they are given this, you have to take 1 meter is equal to 1 centimeter. Okay, now it is 5 meter long, 4 meter wide, and 4.5 meter height. Okay, now you see here, this is VP, HP. HP, as this is VP vertical plane where you have the front view. HP horizontal plane. You assume this as ground here afterwards in application problems. HP horizontal plane. You assume it as a ground. Assume that this is the room. Okay, please follow. I do slowly. This is the room. Always these room measures as you see here, this is 5 meter long, 4 meter wide, this is 4.5 meter high, length into breadth into height. Okay, always, preferably length and breadth can always be interesting, nothing will happen, but better for simplicity, length you always take parallel to VP. Okay, in that way, length you see 5 meter, this way you take. Okay, length is 5 meter, 4 meter perpendicular to VP you take. This 5 meter should be parallel to VP. Okay, and anyway, this 4.5 meter is the height of the room. Can you understand? This is the room. This is 5 meter. I am looking from here. Can you understand? I am looking from here. Observer position, front view is this. In that way, when you are looking from here, length should be better. Okay, I am telling you, you can always interchange 4 and 5. But length, preferably length is parallel to VP, you take 5 meter. This is 4 meters, okay, perpendicular to VP, and height of the room is 4.5. In that way, length, breadth and height, I have drawn the room in isometric. These things you don't have to do. I am telling you only to make you understand I am doing all this. Okay, and as you know, once you do this room, this is isometric. This you come across these types of problems, isometric projection later on. Okay, once you do this, this is the ceiling of the room. That is top surface of the room. This is the ceiling, roof. This is the left wall. Can you follow? This is the front wall. And you can say this is the right wall. This is the back wall. And this, you understand, this is compulsorily the floor or ground of the room. Can you understand, all of you, please? This is the ceiling of the room, please. Ceiling of the room. This is this portion. This is the left wall. This is the front wall. Front wall. When you're looking from here, this is the wall nearest to the observer. This is the front wall. Okay. And this is the ground of the room. Okay. This is the ground of the room. Now, for this problem, what they given is, okay, there is a fan motor. That is, that fan motor is hanging from the ceiling, from the center of the ceiling. It is coming 0.8 meters below the roof. Below the roof. This B is the fan motor, which is hanging from the center of the ceiling 0.8 meters below the roof. Okay. And they've asked you, see here, this is the fan motor. And they asked you to find the true length between this fan motor and any one of the ground corners of the room. You see here, these are all top corners of the room, correct? No? These are all top corners. Ground corners means this can be ground corner, this can be ground corner, this can be ground corner, this can be ground corner. This is the ground corner between front wall and left wall. Okay. This is a ground corner between back wall and left wall. This is the ground corner between right wall and back wall. This is the ground corner between front wall and right wall. They have asked you to find the true length between this fan motor B and any one of the ground corners of the room. Can you understand? That's why you take either this point anywhere you take. Either you take here or take here or take here or take here. Anything you take, the answer will be same. Okay. See here. Now the fan motor is here and they have asked you to find the true distance between one of the ground corners and the fan motor. If you take this in the front view, it will not be parallel. Okay. Or in the top view also it will not be parallel. It will not be in its true length either in the front view or the top view. Okay. Now you see here. Now what you have to do in the examination, I tell you. This, if the problem is given this way, what you have to do in the exam is draw XY line, draw VP-HP. Okay. Once you draw this, when you're looking from front view, when you're looking from the front direction, what you can see, this front view, this wall, front wall can be seen, no? How much is that? 5 meter by 4.5, correct? No? 5 meter by 4.5 meter you can see. That means if it is 1:100 scale, you see, scale 1:100 means this you take it as 5 centimeter or 50 mm. This you take it as 4.5 centimeter or 45 mm. Okay. This is the front view of the room. When you are looking from here, front view of this room is this. That is, length and height can be seen in the front view. And when you are looking from the top, okay, height cannot be seen. Length and breadth can be seen. The breadth, that is when you are looking from the top, no. This is anyway parallel to VP. This is 5 meter means this is 5 meter only. This is 4 meter. That is breadth of the room is 4 meter. You take this. 5 meter and this is 4 meters. This is length of the room. This is breadth of the room. Now you carefully follow. You have written the front view of the room and the top view of the room. Once you have written, write the fan motor. Fan motor, can you observe that it is 0.8 meters from the ceiling. Ceiling is this now. This is the floor of the room. And you know very well, this is the front wall, this is the left wall, this is the right wall, this is the back wall. And clearly understand, this is the roof of the room. Okay. This is the floor of the room. Okay. This is the roof, this is the floor. And this B is at the center of the ceiling, hanging 0.8 meters from the roof top. Okay. That is why from the top, no, you take B dash 0.8 meters or 8 mm, you take B dash. And in the top view, this will be at the center only B. Okay. B dash and B you locate. That is in the front view. Okay. This is anyway, this distance is parallel to VP. And you can see in the front view. And it is at the center. From the center you take B dash. In the top view, compulsorily you take at the intersection of the diagonals, this B point you take, so that it is exactly at the center of the ceiling. And they have asked you to find the true distance between one of the ground corners. Ground corners means, you see here, A and A dash, you carefully see. A dash, if it is here, it is the top corner. I want ground corner. You take this A dash here only, compulsorily. A dash can be here or here. Okay. If you take here, it will be the back corner. If you take here, it will be the front corner. That is between the front and the left wall. Now, once you have this A and A dash, it is clearly, it is one of the ground corners, A dash, and you take A here so that it is at the intersection of front and left wall on the ground. Now, A dash, B dash you have, AB you have. In that way, you are having front view and top view of the thing, and we'll continue this in the next session. Thank you very much for watching. We'll continue the same problem. Thank you.